of such a multiprocessor. One is symmetric, or another one is symmetric. Symmetric usually means the unique same, so which means each process works for the same task, all tasks in the symmetrically distribute the job. And asymmetric is some processor assigned a specific job and the other aren't. So this is the diagram to illustrate the symmetric multiprocessing architecture. Okay, each CPU has their own register, their own cache, but they share the memory. Is this simple? Is this simple? No, because you need to. So for each one, they need to actually, for example, if the data is changed here, you need to know whether this data is changed or not. So this symmetric implementation is much more expensive than asymmetric. Okay? Nowadays, we prefer to use the multi-core system. This is not a system architecture class, so we are not going to details such a multi-core system, but the multi-core system is physically it is implemented on one chip. Okay, but each one has their own register and thread. Okay, but because it's in the one chip, so their communication is much faster than the symmetric, the multiprocessor. Okay. However, sometimes if you want to get the full benefit of the multi-core system, your thread should be distributed by the core. So some students complain. So I purchased a quad-core system, but when I learn the program, which cannot get the 4 times of the speed, if your program cannot be distributed by the core, so you can still use only one core. Okay, depending on your program, sometimes it can be automatically distributed by the core thread. However, sometimes not. So that is the reason multi-core programming. I think we have the parallel programming class. Yes, we have. Yeah, I think that we had Oshif Mahmoud. He offered if you are interested in the multi-core programming, you can take that course.
So one core means one thread.
So one core means one thread. This core can process one thread. Okay. But physically, they are implemented on the one same chip. Okay? So we can view as the multiple processor, but this one is in the one chip, so which means their communication are much cheaper than the symmetric processor. Okay? This one should be connected by the memory channel. Okay? However, multi-core system is on the same chip, so it is much cheaper than multi-core. Multi-core is much cheaper. Okay. And also we have nowadays the cluster system. Then finally the cloud system. Okay. Cluster system is kind of parallel system. Okay. So we can have the computer. Okay. The multiprocessor is on the one computer box. We are using one operating system. We have the multiple processor CPU, or sometimes the multi-core CPU. But the the cluster system we have such a many computer. Then this many computer build one cluster system. So this is the cluster system. Okay. With the thanks of the storage area network. Storage area network is based on the optic networks, which is very fast. I don't know how much fast, I forgot the speed. But anyway, so using that one, sometimes you don't have to keep all the storage as a local. You can connect you have the multiple computer, then you have one storage. They are connected like this. It's a shared nothing, and only share the hard. It's a shared the hard disk drive. Okay. At that time, you may not realize the speed gap between local and such a storage because we can use the optical network, which is very fast. Okay. Also similarly, we can have the asymmetric clustering and the symmetric clustering. And just like the symmetric processor, asymmetric processor, and the asymmetric cluster, each node can work further differently. But on the other hand, the symmetric, the computer node in one cluster will work for the job application. Mostly when we are saying the cluster system, we expect the symmetric clustering because using the symmetric clustering, we can expect the linearly increase the speed, okay? Scalability, linearly increase the scalability. So this is called the high performance computing. So, but I think that you heard about the nowadays high performance computing used for cloud computing system. So cloud computing system, we will see a little bit about the cloud computing system later. Okay, so this is the overall, it's the same as this one in each computer. And they are formed by the one cluster, then they are connected to the storage area network. Like for example, EMC. EMC is the vendor to provide such a storage. So it's kind of one node. So each node, each storage can act as the one computer, but mainly it's for the storage. If you already took the computer architecture class or the other computer science subject, this is so boring because it's just a review of such a computing architecture. Otherwise, if you forget or if you want to review such a thing, just without any stress, just take it. Okay, so in operating system structure, we have the multi-programming architecture and also time-sharing architecture. What is the difference? Multi-programming and multitasking. Okay? Multi-programming and multitasking. Have you ever used the MS-DOS before? No?
Yes.
Yes? What is the DOS? It's an operating system.
This operating system.
Up to Windows 95.
I took this one now.
95, 98?
95.
95?
After that, 98, it's coming with a new system.
Sure. Anyway, this is the operating system.
Yeah, we will
it's
do this
old operating system. So when I learned the computer first time, I learned how to copy. It's a DOS command.
Yeah,
Okay? Then at that time, those how many processes can you run in those programs? One. That is the single program. Okay? Opposite of the multi-program. Nowadays, when you are using Windows 8 or Windows 7, how many programs do you run? Many. Multi-program, multi-job. What about this one? Many? It's a little bit tricky. Okay? If you run the many program, it consumes battery. So, intentionally, if I, for example, even though I currently running several programs, actually it's a disabled background. It doesn't run. Only background service running, and your application actually is not running. If you swipe, change the program, it is disabled to save the battery power. However, in most of the operating system, it's still running, even though I cannot see that one is still running. For example, this time the Windows running several programs same time. That is a multi-program. What about the multitasking? This is a multitasking. How many processor we have here? One processor, which means I can run one process, but I can run many processes. How?
Divided the time for
It's a time sharing. We can share the time. Sometimes we may not realize whether this is running the other process or not. Okay? This is one of the common mistakes. When we share the time, can we increase the CPU time? No, CPU time is a fixed, it's a time, okay? But maximum we can have the 100% utilization, okay? That's the maximum. That is the reason everybody complain the own laptop or computer, because that's limited. We cannot stretch out the time, CPU time, okay? So that is the multitasking. How can we do that? How can? So we need to schedule. So this time from 0 to 1, you can use this one. And 1, 2, 3, you can use this one. And how? How can we schedule?
Based on the priority.
Based on priority, based on starting time, based on importance. So there are variety of reasons. So we will learn such as CPU scheduling in chapter 4, 5, 6, and something like that later. Okay? Mostly it's a priority. Okay? And also we can do the job scheduling in case if we have only the one CPU at such a single program, the operating system, we need to schedule such a job by job, process by process. That was the problem actually. So, since when Bill Gates developed Windows, before Windows, he developed the MS-DOS and DOS program, it's a simple operating system. On top of that, he added the graphical user interface, but change it into the operating system, that is the Windows 3.1. 3.1, it has the Windows 3.1 operating system as well as MS-DOS operating system.
Yeah.
There are two operating systems, okay, that cause the problem. It doesn't make sense. There are two, the kings in one nation. So fight each other, that makes us some confusion. So that is the reason from the Windows 98, I think so it was in Windows 98 or XP, the only is called the CMD, Command Line Interface, not the DOS. Okay? They throw away the MS-DOS from that. Okay, so this one shows the multi-programming system. So we can, this is what? This is a memory. In the memory, we can load many memory, which means many processors at the same time. However, CPU need to select one of them at the same time. That is called the CPU scheduler. We will learn such a CPU scheduler algorithm. Even operating system, definitely, because the computer system is based on the interrupt-based, so operating system also interrupt-driven. So both the hardware and the software, so operating system can understand the control such as interrupt. Also, interrupt, the operating system has the dual mode nowadays. What is the dual mode also? Dual mode means the operating system. So think about, suppose that you are developing the operating system. Is it difficult? Yes, probably difficult. But anyway, after you understand the operating system itself, it's not very difficult to develop the operating system. Many people are doing sometimes just for hobby. They rebuild the kernel and so on. But when you develop the operating system, what you guys need to do? Anyway, you need to control each and every device, and probably you will think about design several functions that are used in operating system. Read the data, open the file, or send the signal, or make the interrupt signal. Several functions that are system call. This is not here, system call. Okay? It's used for only system. So these system call are critical function to access your hardware and memory directly and I/O device directly. So very critical. So if you allow for general user, end user to access such a system call, sometimes you need to give all the permission. which means what if the memory is replaced by the end user? You will be confused. So we are going to separate such a user function and system function. System function such as read the data and write the data, or there are 230 different functions, okay, used in the operating system. This function will be performed by the system. That is called the kernel mode. For example, in your programming, so I like to read, open the file, okay, foo.txt, read, write. So when you run this function, this is a C++ function. Then this function will call open system code. It's a system function. This system function will be performed by this user, this process, no. Change it into system, kernel. Kernel will take over the job. Then run the system function. Then output will be returned to the user. User means user process. Okay? So there are two modes. One is user mode. Another one is kernel mode. So kernel mode, during the kernel mode, so you can operating system will process the system function. Okay? For security reason and some safety. Okay? That is the user mode and the kernel mode. So this slide shows the transition from the user mode and kernel mode. This is a user processor, so user processor will execute. But in case there exists any the system code, system function, so that system function will be taken by the kernel. Kernel will be in charge of to execute the system code. System function, we will see the details of the system function later. So roughly each operating system has more than 200 different system functions. Then when you develop the operating system, you need to implement such a system function. Okay? And also you can add some more algorithms that we are going to run. Then once this is done, you can return the output to the user. Then user can see the open the file like this here. This is the transition from user mode to kernel mode. The next, the process management. Okay. Actually, most of the contents that we can see over here will be discussed in detail from the next week. Okay, so you don't have to worry about too much. It's too fast, or I don't understand anything about that. It's just the overview of what we are going to learn throughout the semester, or some review of the contents that you covered in, that you learned in your computer architecture or the other computer science subject. Okay. So in the process management, we can do such a thing. Definitely, that we can create or remove, delete the process, or some communicate. Okay, sometimes suspending or resume the process. Okay, and privilege. So in the first, not first exercise lab, is the warm-up process. Warm-up the project. You are going to create the two. First, you need to create the main process, your program itself. Then from your program, you need to create the two more, the children processes. One of the students asked me, what about the Java? Java consider all the object as thread. We will see what is a thread. Thread is a kind of process. Okay, but it's different. But anyway, the Java consider when you create the process. Actually, you can create the process, but that will create the thread. Okay. So, however, when you create because it's running on the Java virtual machine, so if you create such a thread, actually you can communicate through the global variable. So It's not a big problem. So I'm not going to allow to use a global variable. Instead, you need to implement communication method, either using the socket program or the IPC and other Q or others. So using such a communication method, you need to communicate each other in case you are using Java. Otherwise, if you are using C or C++, you can create a process. Okay? You can create a process using the fork and exec or create process function. Then using the communication method between or among the process. Actually, not among, because the main process and child process, as long as you can communicate the child process, so you can send the message or you can send back the return message, which one is winner. You can implement the scissor rock paper game. Yes?
But Java is multi-threading, so can't we use that as a parent process and a child process?
It doesn't matter as long as you implement the communication method. Okay? So Java, because this program is a warming one, it's not the major project, for the student to be familiar with the handling the process or the communication method based on your previous the subject you take before, including network or the programming. But nowadays it's mostly Java. So I am going to allow, one time I prevent to use the Java, only the C or C++ program. Many of the students complain. So you can use still the Java, but but when I allow the student to use the Java, they use it just to create the global variable. That's it. Okay. So instead of the global variable, you need to communicate each other. Okay. Why don't you record the programming in network, the class? Okay. The socket program, or that is I think the easy and best way. Socket program is you can create the socket, the one, then the other. So using the TCP/IP protocol, you can easily communicate. Okay. If you never use the socket program, it's not very difficult. Okay. It's a very simple. I think that you need 5 to 10 lines of code for connection. Okay. So that's the first one. Anyway, in the process management, so we will cover such a topic. So this slide shows the general structure of the process. Each process consists of the 4 parts mainly: text segment, data segment. Actually, the data segment, before data segment, it has a global variable, and the data segment and stack segment. What is a stack segment? What is a stack, by the way? During the winter break, I visited China, and I taught the one course in undergraduate. It's a sophomore student. None of them understand when I say the step, because they learn the step in Chinese. Anyway, what is a stack? Stack is a kind of stack up. Okay, you can pile up. It's a first in,
Where's that?
last out. Where did you learn the step? Data structure class. It's the data structure. It can be used for only the memory. No, it can be used for various computer science. Even we will see some of the examples during the semester that utilize the step. Anyway, this step is used for what? Temporary data. Can you remember that your assembly class? If you wanna save the current register information, how can you do that? Anyone? Push all, right? Push all, what happened? Push all the register information to stack. So stack is, actually this is a higher address, this is a lower address, so it will be stack up from the higher address, then increase to the lower address, unlike the data segment. Data segment will be increased lower address to higher address. It's a permanent until this program is died, killed, or terminated. Okay, that's the difference. Stack is usually used for temporary data in your program. Why? The data segment is the permanent data in your program. Then global variable is different. Global variable should be located and separately in between the data segment and text segment. That is the reason probably you learn in your programming class. Do not use a lot of global variable, right? No? Which one is better? The more global variable or less global variable? Definitely less global variable. Why? Because it resides on the lower memory. Lower memory definitely is the scalable and the faster. Okay? It cannot be cleaned up until this process is alive, which means garbage collector will not touch this one. What is the text segment? It's your code. Okay? Your instruction code will be saved here. Who used this data structure? CPU. CPU will access, in case the instruction will access this code segment using the code segment C as the register, okay, and IP instruction pointer. Also, your data will be stored at here. Then, in case push all or temporary, the data, the stack will be used from here. So this is the overall data structure.
Which one we call the heap?
Which one? What?
Heap data section. Heap memory.
Heap is here. This is a heap. It's from data segment. Heap is a data. Okay, and stack is a temporary data. Okay. So when you run the garbage collector, it will first check from here, okay, whether they are valid or not. If not valid, just clean up. So that is the reason heap is grow upward. Upward means from lower address to higher address. Stack is a higher address to lower address. Because I realized that many of the students actually confuse such a grows downward. What does that mean? So that is from higher address and lower address. Who determines such a data structure? It depends on first the CPU. Depending on the CPU, it's different. Think about whether it's 16-bit or 32-bit, 64-bit. Then your compiler should know such a data structure. So when you compile, even though you have the same source code, but depending on the compiler, it can be sometimes 32K, it can be 64K, it can be 1 megabyte. It depends on the architecture. It can be various. So this is the screenshot to list up the whole process. You can see it's in case of Unix, Linux, doesn't matter. So you can see the list of the process ID, and this one is a parent process ID. Why? Because when we create the process, it's like the tree structure. From 0, we create the 1, 2, 3, then the 1 create the 284, something like that. Okay? This is a tree structure, process tree structure. Most of the operating system use such a tree process structure.
So did you say the compiler decides the structure for the memory?
Oh yes, not memory. This is a process structure. Your compiler should know.
I mean,
Okay.
it should know or it decides on its own. I mean,
And then decide when you compile your program, source program, it will actually allocate for example, 32K size of process and 0 to 60K, for example, 8K will be used for the text segment and so on. I don't think we have the compiler class, but if you take the compiler class, you will learn actually most of comprehensive such a data structure. You should understand computer architecture, operating system, program language, data structure, and automata, and most of this. It's really compiled class. Not easy. Because of that, I think the professors are scared to offer. I'd write, but I do not have many background in the computer engineering, so it's very limited. But it's true. The compiler is one of my favorite class. I keep asking other professors to offer, then I try to audit the course. Okay, so this is the screenshot to see the resource is occupied by the process, actually for process communication. It's called the IPC, inter-process communication. The two communicate between the two processes, they need to have the communication method. First, the one is the IPC. IPC is the inter-process communication. This IPC can be based on the shared memory. Sometimes it can be semaphore. Okay, it can be message queue. So this one will be discussed later. So this slide shows such a screenshot. What kind of the communication method I use. Okay. Is it 4:30?
No, it's 4, 5, 10.
Sorry. Okay, so 4:30. Oh, by the way, how many of you are taking the engineering 400? Oh. We will see.
All of
So
them.
the next one is the memory management. Okay. This semester I have the 230, 240. Okay, so memory management. Anyway, the process itself is the memory. So, however, the main problem is the size of memory is not enough to keep all the process. So we need to be smart. We need to share the memory, which means we should have the certain algorithm to maximize the utilization of the memory, but to increase the performance. If we have a lot of in and out, if we have a lot of replacing the current process, that's not good for the definitely performance. So we are going to learn how to make the smart or the best performance of the process, such a memory management. Basically, it's based on page. So you probably heard about the page. Page is the unit, I/O unit of the memory. So that is the reason if you turn on the task manager on your Windows, you can see some number of pages.